Hey, it's Ross from rosslukman.com. Today I want to talk to you about a really interesting device from Victron Energy. These are the battery protects, and as the name implies, they are going to protect your battery whether you have a lead acid or lithium battery. They are going to shut things down when your voltage gets to a certain cutoff voltage. It's going to break the line and preserve your battery. Now there are three different sizes, as you can see here, and there are three different ways that you can use these, which I'm going to show you in this video. So let's just go over the sizes. We have a small 65 amp, which I use really 95% of the time. We have a 100 amp, which I use occasionally, and we have a 220 amp model that I bought originally, but I rarely use these days. And I'm just going to show you some use cases, and at the end of this video we're going to look at how to program them with the Bluetooth signal. So the Bluetooth smart editions of these will connect to your phone or tablet, so you can program them that way, and you can also remotely turn them on and off. So you could do something cool like wire your lights through one of these and turn it on and off with your phone if you want to impress your friends, and have the lights in your van or RV go on and off via your phone. You could do that. I don't really use that as much. I mainly use the Victron Connect app in the phone to program these, and then I just like to hardwire them and let them do their thing. But we can also look at the old school way to program them using a programming wire. We'll take a look at that in just a bit. But I've got some interesting system layouts that I'm going to show you, showing the three ways that these can be used. So the very first way that they can be used is as part of a larger battery management system. And the Victron Smart Lithium batteries have a little battery management system which is going to reach out and shut down your chargers and your loads, and it needs a little device in the line where it can break that line. And these battery protects are going to be used in that scenario. So that's the scenario one I'm going to show you. The second scenario where you can use these is they can be programmed to shut off at a certain voltage, like when your battery gets to 10.5 volts, they'll shut down themselves. But they can also be wired out to a switch in your control center where, let's say you're going to leave your van or RV for a month or two and you don't want any parasitic loads. Maybe you turn off your fridge, you turn off your lights, you think everything's off, and a lot of us come back and sometimes your battery is drained and you're like, what is draining my battery? So one of the ways to avoid that is just to connect, let's say, your 12 volt fuse block, all your 12 volt loads, your heater, you could do your air conditioner, your lights, your refrigerator, everything would go through a 12 volt fuse block. And you could wire the battery protect in line with that fuse block and wire this out to a cutoff switch. When you're going to put your vehicle in storage, you could just turn that switch to off, and the battery protect will break the line so none of those loads can get to your battery to drain it while you're gone. So that is the use case 2 where you have a switch. And the use case 3, which is probably the most common, is you're going to just add a little horseshoe jumper wire. You can see here on this 100 amp, it's got the little jumper there. Basically, when you jump those two terminals together, the battery protect is going to work autonomously, and it's just going to monitor that voltage. And when it gets to a set point voltage, out of the box it is 10.5 volts, at which point it will shut down. But I'll show you later, we'll program it. You can have it shut down at different voltages. But basically, when it hits the voltage that it's programmed to shut down at, it's going to break the line itself and cut off all those loads, or in the case of our scenario 1, it can cut off chargers as well. Show you that in just a second. So those are the three use cases as part of a battery management system, with them hardwired to a switch where you can actually shut them down, and then scenario 3 where they're not really wired to anything else and they just shut down automatically when they reach their cutoff voltage. So those are the three scenarios. Again, we're going to look at those in real life here in just a second. I'm going to have these wired into a system, a couple of different systems. But before we get into looking at how those systems are wired, if you're interested in your overall van or RV electrical system, I have a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of the 3 major charging sources for a van or RV, which are shore power, solar power, and alternator power. And it talks about how they all have strengths, but they also have weaknesses. But when you combine them, they are going to work together to make sure you have a good charge no matter where you find yourself out on the road, whether you're plugged in at a campground or you're boondocking way out in the desert. You're not going to have to worry about charging your batteries, and you're just going to be able to enjoy your trip. So there's a discussion about the 3 different charging sources and how they each come into play at different times. Next up, there's a discussion on page 2 about the different battery chemistries, and that discussion is going to help you narrow in on which battery type is going to be right for your project. And then lastly, there is a really interesting conceptual diagram that was originally requested by a student of mine. He wanted to see the overall power system and what are the connections from, say, your solar panel on the roof all the way through the system to where it comes out at your phone charger or your microwave. What are those connections and links that get that charging source, not only all the charging sources to play nice together to charge your batteries, but how do your batteries connect to your end devices? What are all those links in there? So it's a really interesting diagram that I think you'll enjoy. It's pretty much your entire power system on one page. If you want to get your copy of the Ultimate Van Power Cheat Sheet, all you have to do is click that link below or go to rosslukman.com/vanpower. So with that, let's throw these into a system and we'll take a look. All right, so let's take a look at use case 1, using the BatteryProtect in conjunction with a battery management system. This is an external BMS from Victron Energy. This is the VE Bus BMS, and it works with the Victron Smart Lithium batteries. Now, I know this system is a little bit overwhelming. If you want a full explanation of what's going on here, check out last week's video where I talk about the VE Bus BMS and the Victron Smart Lithium batteries. But what I want to do is just point out a few things about the BatteryProtect and what's going on here, and then we'll simplify this system and we'll look at the second 2 ways that you can use these. But as far as use case 1, this is going to have these yellow wires going out to the BatteryProtect. We have charge disconnect and load disconnect. So the loads will be connected here and the charger will be connected here to the solar charger. And these BatteryProtects are going to be in lithium ion mode, and it's basically going to shut down the functionality where they're looking for a low voltage shutdown. They're going to quit doing that and basically turn into little relays that are controlled by the BMS. So under normal circumstances, the BMS is going to send out a 12 volt control voltage down this yellow wire, and it's going to tell them to turn on, let the loads get power, let the solar power come through to the battery, and everything's great. In a low voltage shutdown, it's going to shut down the load, so it's going to pull power from this wire on the load side, and it's going to shut off all your loads to protect the battery in a low voltage scenario. Now with the chargers, maybe the battery gets too hot or the voltage gets too high and it wants to shut off the chargers. Maybe this charger goes haywire and it's sending in a higher voltage than is acceptable. Then the BMS is going to pull the 12 volt signal from that BMS, from that BatteryProtect, excuse me, and it's going to break that line so the solar power can't get to the battery. So those are 2 different scenarios. As you can see, we have power going out and power going in, and you can use the BatteryProtect in both scenarios. I will mention power is supposed to flow in one direction. You'll look at the labels. It says in and out on the lugs, and these are flipped from each other. So in this scenario, incoming power is going to come into this lug and outgoing power is going to go out from this lug to the loads. And then this one is flipped around. Power in is coming into this side, and then out is going on to the battery. So that is how it works. Power can flow. If you have a small current, it can flow in reverse. For instance, at night, the solar panels are not going to be powering up the solar charger, but it still has to stay on and kind of wait for sunset. And it's going to draw a small current from the battery so that it can monitor what's going on outside, basically stay on. And that current is going to flow in reverse through the BatteryProtect. So it can take a small reverse current, but you don't want to send 200 amps in the wrong direction because it will burn up the internal components. Now I do want to mention too, I would typically use the small 65 amp unit for both of these scenarios. I didn't have another 65 for this setup last week, so I used the 220. It'll work, it's just kind of a waste of money, but here is a system that I did that has two of the small 65 amps. One is on the 12 volt DC loads and one is cutting off the solar. So that's what that would typically look like. I do want to mention on the 100 amp unit. So this is the 100 amp unit. A lot of times I'll use it as my 12 volt load cutoff when I have a 12 volt air conditioner. So I would typically have a single line come into the incoming lug, and then on the outgoing, instead of going just to the fuse block, I'd have one line going to the fuse block, and then I'd have a second line running to a fuse. Typically the 12 volt air conditioners will have an 80 amp fuse on a single fuse block that goes on to the air conditioner. So you'd have one line going to the main fuse block and one line going to the air conditioner out of this 100 amp unit. So those air conditioners will take about 50 amps maximum, and it just uses too much of the 65 amp capacity. You only have 15 amps left over for all your other 12 volt loads. Truthfully, the 65 amp would probably run all your 12 volt loads and the air conditioner, but I like to beef it up a little bit and have a little reserve capacity. So I will use these 100 amp models when I have that 12 volt air conditioner in the mix. So that is my wrap up for scenario one. Let's break this thing down and simplify what's going on here. We're going to look at the second two use cases, and I'm going to show you how to wire these and program them. Alright, so I've simplified our system quite a bit. You can see we have system positive, system negative. We've got positive running through the BatteryProtect here onto our 12 volt DC fuse block, and we've got a little puck light there to give us an indicator as to whether the power is getting through or not. And we also have a ground wire here. If you look at the labels on the side of the unit, it's going to tell you program, ground, alarm, and remote. So those labels are here on the bottom of this unit. We've connected the ground terminal over to system negative. So in 12 volt systems, ground and negative are pretty much interchangeable terms. So ground goes to negative, and that gives the unit a positive and a negative charge, so it can assess the voltage of the battery and decide whether or not to shut down. The last thing that we have here is our little horseshoe going into the remote terminals. And as I said earlier, that allows the unit to work autonomously and shut down if needed in a low voltage scenario. So if we turn on our battery switch here, this will initialize, power will go through, and our light will turn on. So we are operational, but at this point, let's say we decide that we want to change the settings. So these have a mode and a voltage setting. The mode right now is mode A, and I use that in 95% of the cases. That is the LED/buzzer mode, and basically there is a port here that's called alarm. So when it goes into a low voltage shutdown, it will trigger that particular port. It'll apply a voltage there to turn on an alarm or a little light to tell you that you've gone into a low voltage shutdown. Now, I don't typically use the alarm port there, but I use mode A so that I can just program in the voltage setting that I want, and the unit will shut down at that low voltage point. So it's going to default out of the box as mode A and voltage setting 0. So we have voltage settings 0 through 9, and these are all listed in the instructions that come with it. But let's say that mode 0, it's going to shut down at 10.5 volts and it restarts at 12 volts. Let's say we don't like that and we decide that we like mode 3 better. So we will go from A0 to A3. Let me show you how to do that. So to program it, and by the way, this is the old school approach. I'm going to show you the Bluetooth, how to program it with the app in just a second here. So to program it, we're going to disconnect any loads off of the unit. And we would typically just disconnect this cable here, but to make it easy, we'll pull this fuse. So we've eliminated any downstream loads from the unit. And you also want to pull out your remote cables. So anything in the remote terminals, just go ahead and pull that out. And the unit is off, but you can see that it still has positive and negative. So it's kind of asleep, but it's still getting power. And this is the scenario where we can come in and program it. So how you're going to do that is there is a terminal called PROG for program. So that's that far terminal there. And we're going to connect that terminal to system negative, and the unit will scroll through its settings. And then when you get to the setting that you like, you just pull the wire, either disconnect it here or here, and it will stop at that setting and then flash to confirm that setting. So let's take a look at that. So we'll come in here with this separate wire. See if we can get it in there. All right, so we'll leave the negative connected, and we basically have a second negative coming in here. And you'll see these numbers scroll as we go through. So I'll touch it to system negative, and it's on setting 0, and we'll go to 3, and then we'll pull the wire. And it's going to go A3, A3 as it confirms. Now let's say that we want to put it in mode C. We're going to use it with the BMS like we showed in the last example. We want to put it in lithium ion mode. We're going to touch it. It's going to confirm A3, A3. We're going to come back and touch it again. A, B, C, and then let go. And it's going to confirm C3, C3. So we've now put it in lithium ion mode to use with the BMS like I showed in the first example. So that's how you would change the mode or the voltage setting. And again, this is covered extensively in the instructions, but that's basically how you would do it in the old school way of changing those settings. So at this point, let's bring up the phone and the app, and we'll take a look at how you would program it that way and some additional functionality with the Victron Connect app. I've got the Victron Connect app pulled up on my phone, used a little double-sided tape, stuck it to the board there, and we're going to take a look at how the phone controls the unit. But I wanted to show you the third scenario that I mentioned, which is controlling this with a switch. Now on the side of the units, it'll say remote and it'll say H and L. So H is for high, L is for low, and we can call it a high side and a low side. So the H port is going to connect to high, which would be 12 volt positive, and the L side is going to connect to negative, so, or ground. So we can ground out the unit and it will turn it on. So that's the scenario that I have right now. So we're connected to the L port, and I've connected it to system negative. The unit is on, our switch is on. Now if I turn the switch off, I'm going to break the connection to ground, and the unit goes off. Turn it back on. Now, I will say this switch is what I use these units for most of the time. So I mentioned this earlier. I'm going to put this switch in my control center, and you have a convenient way to shut down all your 12 volt loads, or you can shut down other devices, but you can hit a switch and shut down an entire bank of loads or a large inverter by just hitting that switch in your control center. This is great when you're going to put your van or RV in storage for a little while, and you're not going to have to worry about parasitic loads damaging or draining your battery while you're gone. So the switch is really handy. I have to say, with the Bluetooth, it's neat to be able to control it. So the toggle here will shut down the unit. You get a little warning there, but you can see I'm able to shut it down, and I can turn it back on. And that's really neat, but I have to say I don't use that functionality a lot. As I mentioned earlier, I'll program the unit with this, and pretty much from then on it's just operation by the switch. And of course, when the switch is on, the unit is still assessing the voltage and it will do its low voltage shutdown. So even if you have the switch on, it can shut itself down when it hits its low voltage threshold. So let me show you one other thing. We are going to connect to the high side. You can see I broke the connection to ground. The unit goes off. So let's move this wire over to 12 volt positive. And you can see it's still off, but if I move from the low side, let's move our wire over to the high side, and you will see the unit now turn on. Okay. So it's pretty neat. You can operate the unit by connecting it to ground or to 12 volt positive. And I will mention too, ignition wires or ignition signal wires also are a 12 volt positive signal. So you could potentially control one of these with your ignition. If you want to, you could have that ignition wire come in, go to the H, the high side of the remote ports, and that unit will turn on when your vehicle turns on. So that could be pretty neat as well. But that's pretty much the demo of the switch and the toggle ability. Let's go ahead and zoom in. Actually, I want to mention one more thing. If you get a Bluetooth edition, a smart BatteryProtect, and you want to disable the Bluetooth, you can do that with the old school programming wire. And remember earlier we had mode A, mode C. There is a mode F and a mode H. And when you let it run down to H and F, that will turn on and off the Bluetooth. And it's in the instructions. But if you, let's say you have the batteries are putting out Bluetooth, solar, your battery monitor, you go into the app and you just have a list that's very, very long and you're not really using the Bluetooth capability for this, you can turn it off so it eliminates it from the list by putting it into the H mode with the programming wire, and it will kill the Bluetooth signal. So that is possible, and of course you can turn the Bluetooth signal back on by putting it in the F mode. So I hope that made sense. At this point, let's go ahead and zoom in on the app and take a closer look at how to program it. I've zoomed in on the app here, and we have the two items that have Bluetooth in the room showing up. We've got the Smart Lithium Battery and the BatteryProtect. So we will click on the BatteryProtect, and it's going to take us to the main screen. It's going to give us the battery voltage and tell us what state the BatteryProtect is in. So currently it's active, power's flowing through. If we hit our toggle, it's going to give us the warning, and then it'll shut down. And this is how I was turning the light on and off earlier, so we'll reactivate it. What I wanted to show you is mainly this gear icon. So we'll hit the gear and we'll go into the settings. So it's auto detected that we have a 12 volt battery system. You can change that to 24 volts there. Next up we have the under voltage settings. So this is settings 0 through 9. And you can also do user defined where you type in your own shutdown and restart voltages. And then we have the mode here. So as I said, I use mode A most of the time, but you can select A, B, or C here. So relay mode, I didn't talk a whole lot about mode B. That's basically going to, instead of connecting an alarm to the alarm output, you're going to connect a wire to the alarm output that goes to a relay to turn something on. So you could turn on your engine to recharge the battery, or you could turn on a generator or some kind of charger. Basically, when the unit goes into a low voltage shutdown, it will activate the relay to turn on some kind of device to recharge the battery. So that could be pretty handy. And then of course we have mode C, lithium ion mode, which I mentioned when you're running the BatteryProtects as part of a battery management system with a Victron BMS. You can put it in lithium ion mode. And then here you can just change the type of alarm, relay or buzzer LED, in normal or lithium ion. And those are also changed when you select your mode. It will populate these, as you can see there. So we'll turn it back to A and it'll change those as well. So that's a little bit more about how to use the app with the Smart BatteryProtect. That's my review of the Victron Battery Protect device. I hope that was helpful. If you want even more help with your van or RV electrical system, you got to check out the Ultimate Van Power Cheat Sheet. To grab your copy, all you have to do is click that link below or go to rosslukman.com/vanpower. So thanks for watching, and I'll see you in the next video.